Hello and welcome to another Creative TD production. In this particular video, what we are going to cover is how to set up a Vertex program so you can actually read in your Vertex colors that you paint and Vertex Alpha. You can manipulate the positions of the vertices for something like a waving flag. Lots of things you can do. It's always useful to be able to utilize the data that's already there, such as a vertex, to create a ton of different types of effects instead of having to completely rely on textures to provide you the information of how you set up your shaders. So really we're just going to go over how to set up the Vertex program itself instead of a surface shader, and just learn how to get the data moving around. Okay, so here we actually have a vertex shader, okay, and it is displaying the current colors of the normals of this model. Okay, so we're going to start with that. What I'm going to do is just put on a I'm going to make a new material here. Let's call this default matte, and I'm going to drag that onto that. That way we have something to start from. Alright, and then I'm going to go create a new shader. We're going to call this our Vertex Program Shader. Alright. Now it's relatively easy to produce thanks to the surface shader model. You don't have to worry about transforming all your vertices inside of, or from screen space to world space to object space, all those different transformation matrices that you have to worry about inside of fragment programs, or your standard CG shaders. Okay, surface shaders have basically bundled all that stuff up for you. Makes it a lot easier on us. So I'm going to throw this into my CTD folder there, my shader folder. I'm going to save that. And then just to get this started, all that we need to do is where you're declaring the lighting model that you want to use. Okay. At the very end of it, you just want to add a tag to this pragma statements. You want to say vertex colon, right? That basically tells Unity that, hey, we're going to be including a vertex function with this surface shader, okay? And then after this colon here, what you want to do is you want to give the name of the function, okay? So that way Unity knows where to look for that function. So you have vertex vert. All right, and then right after that, what you want to do is you want to say void vert, alright, because we need it to be the same name as this function that we're declaring up here next to the vertex tag, okay? And then we want to come into the arguments for a vertex function. So I'm going to actually just put in my brackets there. Okay, so the first thing we want to do is we basically want to stream in all the data that Unity is providing us about the model, okay? They give you things like the tangents, they give you things like the normals, the vertex positions, their world space positions, the different matrices you can use to transform the vertices into different positions, in different spaces, I mean. Lots of stuff like that. So let's do that. So we want to get the data, right? And that means that we need to declare an in-out statement right there, basically saying bring in all my data here. And we want to utilize the app data underscore full. Oops. Alright, now app data full includes all that information, so let's go take a look here. Let's go up to the shader reference. And if we go to, let's see here, I think it's in here. It's one of these guys that will tell us exactly what app data and app data full provide us. Accessing shader properties. Is that what it is? Vertex and fragment programs. What's around here? Oh. Well, they do mention it right here, but I guess there really isn't a ton of information. Probably one of the reasons why most people do not know that it's there, especially when you start out by writing surface shaders instead of just doing straight up CG shaders like this, right? So for now, app data full and app data base, they contain information about your model. Okay, so it's telling us here that we can go to our Unity CG include. So if you were to go to your computer, go to your C drive here, and we go to Unity, and we go to editor, and we go to data, CG includes, and we go to our Unity CG include file here, and we take a look, we can probably find app data full somewhere around here, yeah. So here's all the different information that we can pull in and write to. Actually, I don't think you can write to it, but you can pull all this information out. So in app data base, you get vertex normal and one text chord. In the tangent, you can get the tangent normal, right? Then in the full, you get basically everything that you could want. Alright, so just stuff to keep in mind if you ever need to find reference to what you want to use. But after a while of using these over and over again, you kind of know which ones to use. I mostly just use full at first because I don't know, most of the times when I'm starting to write a shader, what it's going to end up like completely. So I always just put down full, and I've memorized what's in there. So let's just move on. Alright, so now we have that. So app data full, and then we need to store that as a reference into a variable there. Alright, and then what we need to do is we need to pass out this information to our own struct. Alright, so we want to actually take the information from our Vertex program and we want to store it into a custom variable that we can use ourselves in our surface function. Okay, so we're going to say out, give it the input, the struct's name. Okay, so we're going to output a type of input there, and we're going to call this O. Alright. So now all we need to do is, I'm going to set up the Vertex Colors to be the Vertex Normals. All we need to do is we need to say, actually, first, before we do that, we need to declare a custom variable. So I'm going to call this my Vert Colors. Alright, inside of our own input. So we can now use Vert Colors inside of our surface program here. Excuse me. So now what we can do is we can say o.vertcolors alright, equals v.normals, normal. So again, O is giving us access to our struct's input and allowing us to write data to it, right? Inside of input, we have a variable called vertcolors. So to access that, we need to say o.vertcolors, okay? And then we want to write some data to it so that we can fill it up with stuff, all right? So then what we want to say is we want to pull in from app data full, which is called v, the normal information, and pass that into vertcolors. All right? So that's all set up. So now all we need to do is come down into our surface program, and I'll just comment that out. We want to say in.vertcolors. All right, we'll save that. We'll come back to Unity. Let it compile. Alright, so then let's go into our model here, and let's go to CTD, and we're going to get Vertex Program Shader. And there you go. Now we have some vert colors. But you'll notice that it doesn't actually look exactly like what we had, and that's because when we're bringing in the normals, we actually have some normals that are pointing in a negative direction, right? So I'm getting positive values and negative values. So to take care of that, all you have to do is say you want to get the absolute value of the V normal. Let that compile. And there you go. So now we basically remove the negative portion of the normal. Just basically removes the negative symbol, right? And now you have all positive vectors. Okay. So how is this useful in a game? Well, again, like I said, you can manipulate the positions of the vertices themselves. Or you can use it as like masking techniques, really popular to do in terms of terrains for games. So let's go in Maya here. I'm just going to do a really quick example of a workflow. And I'm going to make, I didn't want to do that. I didn't want to make a cylinder. I wanted to create a sphere. There we go. So we make a sphere. That's pretty good. And then I want to paint some color in here. Actually, I'm going to apply a whole bunch of color first. So I'm going to apply some color to this. And I want to paint some color now. And what I'm going to do is just do some primary colors, just to make it easier on our eyes. And I'm going to paint RGB and A, right? So we have four values, basically, that we want to paint. And we're going to replace, there we go. Alright, so now we're painting Vertex Colors. Let's go to green. And just paint all this stuff out here. Alright, let's get rid of that little guy. And I'm probably going to just smooth this, just to flood it a little bit with some smooth. Alright, there we go. So now we have a model with Vertex Colors on it. We're going to export this out as an FBX, and all the Vertex Colors will be written into this FBX file. So what I want to do is just put this to my desktop. We'll call this my sphere. Vert Colors, and we'll come into Unity here, and let's go to Objects. Do I have an Objects folder? I should. Models, and I'm going to import that model now. Sphere Vert Colors. Alright, and by default you're not going to see any of the vert colors, right, because a shader is required to produce those colors. So I'm going to throw this guy into our scene here, and we're going to just pull him over to the side here, and let's make this guy a little bigger here, maybe center it out, and then let's move our camera here. Let's move our camera over here. Alright, so now we want to actually just first want to be able to view our vert colors. Alright, so what I'm going to do is just make another shader. Alright, so we'll do it again. We'll call this Vert Colors Model Shader. There we go. And we'll double click on this to bring it up into MonoDevelop here. And let's just get our shader set up again. Alright, so I'm going to call this CTD. So the best thing with shaders is to always just practice, right? So writing your shaders over and over again in the early days is always a good thing to do. Gives you a firm understanding of the things that are going on. Text vert, and we want to do void vert, and we want to do in out app data full. And we want to say out input O, and we need to give this a reference variable. And then basically what we want to say now is O.vertcolors. Whoa. O.vertcolors is equal to V.colors. Alright, and we just want to pull out the RGB for now. Okay? So that should be everything if we take a look at it. And then all we need to do down here is say that the albedo is equal to in.vertcolors. Save that. We'll see if we got any errors. And we do. Oh, it says that colors is not in the struct. It's actually color. There you go. Alright, so no errors. So now we can go into our model here, and let's just get the Vertex Colors model. So there we go. Now you can see we have the Vertex Colors that we painted inside of Maya here on our model. So this becomes really useful because now we can actually do lots of different things. We can mask out textures with these, right? Because if we were to actually take a look and just did in.vertcolors.red channel, red channel, red channel, we will just get the red portion of our vert colors. There you go. So now we actually have a mask that you can lerp between. Right? Becomes really, really useful. It might be actually a cool thing to do. So let's do this on the fly here. So let's copy this and let's just call this our blend text. Alright, and what I want to do is create another one of these. So blend text, and we're going to have it use the same, actually no, we'll just do something different here. We'll actually create our own UVs here. So UV blend text, that's good. Alright, so we will then come down here, say half for, we'll call this main, that's a lame name, call this text A, and text B, alright, and that'll be that one, and then this one will be blend text, and in.uv blend text, alright. So now we have two textures set up, and what I want to do is I actually want to use this mask information here that you see here. Let it compile here for a second. I want to use this mask information to blend between those two different textures that I have. So if we were to actually select this, we have these two textures, and let's put some textures in there just so we have something. Why don't I import some more terrainy looking textures? Let's do it from here as well. So let's go to desktop. I'm going to go to my texture library, and we want to get some, let's do some ground. Where's my ground? You can see my ground? There's grass, there's ground cover. Well, we'll do something like that. Okay. And just pull that off screen. So do that, and then let's do dirt. Do I have some dirt? I've got some dirt here. I do have some substance dirts, but I don't want to worry about that right now. Let's see, there's soil and mud. Yeah, that'll work just fine. Perfect. Alrighty, so let's just go in here. I'm going to set these guys to not generate maps for now. Yep. This will set up some nice compression settings for them. Alright, so let's go into our model here and assign our textures. Alright, so we're going to blend these two textures using this as a mask from our Vertex Colors. Alright, so let's go back into here. And now what I want to do is I want to declare half for, well you don't have to, but half for, and we're going to call this our final blend. And this is going to be equal to CG function called lerp. So lerp allows us to blend between two values based on a float value. Okay, we already have our float value, which is this black and white mask, right? These are all float values. And then we already have our other two values, which are our textures. Okay, so let's go back to this. So basically I want to blend between text A and text B by in.vertex colors are, like so. Well, that'll give us our final color there. And basically, all we need to do then is put that into, put final blend as our final color, just extract the RGB values and throw that into our albedo. And we can actually also put final blend.a for our alpha if needed. Alright, so now we go back to our model and see if we get any errors. And we don't. And there we go. So now we are blending now between two textures. Alright. Pretty cool stuff. So we also then have control over our different tiling rates for each texture. So we can do 5 by 5, like so. So there you go. It's pretty sweet. You can do a ton of different operations. I want to do one more thing now. So if we were to actually, look at our vertex colors again. So what I'm blending between right now is, I'm just saying the R channel. So what I want to do is I want to say wherever it's blue now, it's actually going to be transparent. Alright, so kind of a little peek at transparency. It's really easy to do though, since we're already feeding in all these values. We only need to do a couple things to make this transparent. So what I want to do is actually put in for one of our render types is transparent. Okay, and then at the end of our pragma lighting statement, we want to put in the term alpha. This just tells the Surface program that we are going to turn this into a transparent type shader that includes an alpha. Okay, and that basically gets it all going. So now I can actually bring in for our alpha value in dot vert colors dot blue. Now let's just see what kind of trouble we just caused there, if any. And there you go. We now have a transparent shader. And you can see that it's not blending appropriately with anything, right? It's looking pretty dodgy. Well, one thing you can do to fix that is you can say blend the source alpha with 1 minus the source alpha, right? Basically an invert of that. We'll go over blending modes and transparency later, but this should fix a little bit of that. Or not. I mean, it doesn't really like shadows and stuff like that. We'll do a whole video series on, or not video series, we'll do a whole video on transparency, different blending modes, things to watch out for. But that's basically the cliff notes right there, the quick version of transparency. So I'm actually going to just set this back to final blend.a. Alright. And most likely we'll have to set our, because you can see the blend is, we can kind of see through this a little bit. You want to set this back to geometry and get rid of the blend. And we'll have our model back. So there you have it, Vertex Colors in a nutshell. Hopefully that was helpful for you guys, and let me know if you have any questions, and I will do my best to get back to everybody. Thanks so much, and I will see you guys in the next video.